Hello dear students, if you are a NEET aspirant and you are preparing for this exam, there are certain things that you must understand. Number one, that this exam requires speed and accuracy. These are the two founding pillars on this your entire preparation would be based upon. And how you are going to do this exam, how much you are going to score in this exam will all depend upon these factors. So, you must understand certain things. Number one, when you're studying the concepts, you must make sure that you understand each and every entry detail of the concepts. Number two, you must have better and easy methods to solve the questions. Basically, what I'm talking about is you must know, in addition to regular methods, some additional superior methods which will help you to solve questions in a shorter duration of time. So in this session, let me give you a highlight of how this entire session or the entire crash course is going to be. All right, let's see some topics. First of all, let's talk about balanced Wheatstone bridge. Now, this is a concept which is very, very common and most often asked in your NEET exam. What is a balanced Wheatstone bridge? For that matter, if you look at this circuit is known as a Wheatstone bridge circuit, and it would be balanced if the cross product across this bridge is equal. As you can see, 5 into 6 is 30 and 3 into 10 is 30. So when this is balanced, then what you can do is you can simply get rid of this part. You can simply eliminate this part, because in that case, no current will be flowing through this 6 ohm resistor. And if no current is flowing through that 6 ohm resistor, then simply you can say that this 5 and 3 are in series, which is in parallel with 10 and 6. All right. So you'll have a refined circuit, which is going to look like this. You'll have 5 plus 3, which will be 8 ohm, and another one, which will be 16 ohm. 10 plus 6 is 16, right? And the equivalent between point A and B can be simply written as R equivalent between A and B will be equal to 8 times 16 divided by 8 plus 16. This is how you can simply solve a question of a balanced Wheatstone bridge circuit. But you would say, sir, that's too simple and that is easy, and I know that. Yeah, I understand, you know that. The problem starts when a question is given to you of a Wheatstone bridge and that Wheatstone bridge is unbalanced. That is, it's not balanced. Then how do you solve such a case? For example, take this circuit. If you're looking at the circuit, you can see that the cross product across this, the cross, 5 times 2 is 10, 3 times 2 is 6. So this is an unbalanced Wheatstone bridge. Now, if you ask me technically, sir, how do we solve this? Well, there is a very lengthy solution and would take you at least 5 to 7 minutes to solve such a question. Now, the whole intention of an examiner asking this question in your exam is not just he's asking you to solve this problem. Rather, the question itself is going to ensure that you at least are going to put some 6 or 7 minutes for this particular question and waste a lot of time. Now, being a smart student, you should never do that. So I'll tell you a superior, a better method, a shortcut method rather, by which you can solve such a question of unbalanced Wheatstone bridge. Otherwise, what we have to do? Well, the regular method is simple, that we will take loops and we will apply Kirchhoff's law. We'll have 3 loops because you know that current, you can imagine that this is connected to some kind of a cell like this, right? The current starts from here, I, and it gets divided, let's say I1, let's say I2. So you have got 3 variables, I1, I2 and I3. You will be writing 3 equations based on KVL, and then you'll be solving these 3 simultaneous equations, which of course is a tedious task. And then once you are done with it, then you have to solve for R equivalent, which is again a very, very difficult task to do in that limited time. So what we will do, we'll not go with this method. Rather, I'm going to teach you a simpler and a very important and a vast shortcut method. This is called as delta star. Delta star. Delta star. What is delta? Delta is a triangular circuit like this, and star is a circuit like this. All right. So basically, if you see over here, you have got one delta. This whole thing can be considered as one delta, correct? So we are going to convert this circuit in a more simplified form, and by this method, you will be able to solve this in less than 1 minute. So let us see how do we use this delta star conversion. To convert this circuit into this form, let me just show you that we have a circuit like this over here. We have some sort of circuit like this where you have resistance here, resistance here, resistance here. And I'm going to convert this in this form where there will be one resistance, then resistance here, and then resistance here. All right. So we are going to convert this in such a way that there will be one resistance at this point, then one here and one here. And in that way, we can remove this part, and this part. All right. Eventually, what we are going to get a circuit is like from point A, we are going to get one resistance, then another one, and this part remains the same. Now, as you can see, this is a easy circuit, isn't it? And I'm writing this as, let's call this as R1, let's call this as R2, and let's call this as R3. Same here, let's call this as R1, let's call this as R2, let's call this as R3, and the other ones remain same. This is 3 ohm, this is your 2 ohm. All right. So the whole idea is, how do I find R1, R2, and R3? Now to do that, you have to use a very simple trick or a very simple formula. What is it? See, you need to follow with me, all right, while we are solving this. Okay, just be with me. How do we do? For writing R1, I'm writing R1. Okay, for writing this R1, you need to multiply the two resistances which are across this. All right, just draw a line. It will cut off two resistances, just multiply. So how much do you get? 5 into 2. R1 will be 5 into 2 divided by the sum of the three resistance, which is 5 plus 3 plus 2, which is how much? 5 plus 3 is 8 plus 2 is 10. So 10. So 10 by 10, that gives us 1 ohm. So this is 1 ohm resistance. I hope you understood. If not, I'll repeat the same thing again. See, to convert this 2 into R1, what we did is we drew a line. It cut the two resistances. We took the product as numerator and we took the sum of all the three resistances as denominator. Now, let's write R2. If you write R2, R2 can be written as R2, which two resistances it is cutting? 5 and 3. So this will be 5 times 3 divided by the sum, which is 10, which is 15 divided by 10. So 1.5 ohm. Where is R2? This would be 1.5 ohm. And now write R3. R3, you can cut this off, correct? And as you can see, it is cutting 2 and 3. So R3 would come out to be equal to 2 times 3. That is 2 into 3 divided by 10, which is 0.6 ohms. So this is now 0.6 ohms. So you have got now three resistances. R1 is 1 ohm. This is 1.5 ohm. This is 0.6 ohm. Now, as you can see, 1.5 and 3 are in series with one another. 0.6 and 2 is in series with one another. Together they are in parallel, and which is in series with this 1 ohm resistance. So by using this simple delta star conversion, you can simply do this unbalanced Wheatstone bridge question in maybe some 40-50 seconds. Of course, because I had to explain, it took me a little bit of time. But when you're practicing it on your own, it will be super easy for you to solve such a question. All right. So I hope this idea of how to solve unbalanced Wheatstone bridge is clear. And whenever you get a question of unbalanced Wheatstone bridge, my suggestion to you is, rather than going with the regular method, you must apply this shortcut trick. This is going to save a lot of your time. All right. Moving on to the next important and tougher concept, which comes from ray optics. Now you already know what this diagram means. This is actually a refraction from a curved surface. you have one medium over here, mu1, another medium over here, mu2. There is an object which is placed in medium 1. The light ray is starting from here. It suffers refraction, and then you have an image in this medium, right? What is the formula that you write? Well, we write the formula as, we'll write mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. This is simply the formula of refraction at a curved surface, and I'm sure you must have remembered it. Okay, you must know this formula. Now, there is a very good technique to remember this formula. Rather, that is, where is the final image being formed? It is being formed in mu2. So, first term mu2 by v. Okay, where is the object? Object is in mu1. So, mu1 by u, okay, is equal to this right hand side, that is mu2 minus mu1 by this r. And you must use this formula with sign, And what is the sign convention, by the way? What is the sign convention if I ask you that question? Well, the sign convention, the direction of the incident ray is always positive, and the direction opposite to incident ray is taken to be what? Negative. So in this case, if you see, the curvature is in this fashion, right? So the radius of curvature will lie along the direction of the incident ray, so it will be positive. U in this case will be negative, V in this case will be positive, and R in this case will be positive. Correct? So you must use this formula wherever you're using this, whenever you're writing this formula, you must use it with proper sign convention. Okay. With this much of understanding, let's go ahead and build further more understanding. Now, this is slightly more complicated case. Why? Because I have taken three mediums. This is medium 1, this is medium 2, this is medium 3. Generally, when you solve a question, you will see that most of the time across the lens, the mediums are same. But I have taken different mediums. Also, if you look at the radiuses, the radius of curvatures of the first surface and the second surface is also different. All right. So, how do we work this out? Well, if you go with the regular thing, if you go with the regular formula, you would have simply written for the first surface, you would have written the expression of refraction from the curved surface for the first one. And again, you would have written for the second one, correct? That's how generally it should work. Okay. So, for the first surface, you can see this is the refraction from the first surface, and V dash is the image that we are getting from the first surface. I should have written V dash, where it is getting formed, V dash for the first surface, right? V dash, or let us just directly get into the shortcut formula. Where is the final image getting formed? Final image is getting formed in mu3. So I'll write simply mu3 by V. Where is the object located? Object is located in mu1. So I'll write mu1 by U. Now, here comes the trick. Is equal to, now how many surfaces do we have? We have two surfaces. So, always whenever you are moving across the surface, this is the first surface, right? This is the first surface, and this will be the curvature of the first surface. This is our first surface, isn't it? And as you can see, the curvature of the first surface is R1. So, this is the first surface. You see across the first surface, what is the medium? Mu2. Mu2 minus mu1. So, I will write first mu2 minus mu1 divided by R1 plus. Now, I go to the second surface. And for second surface, I'll write this medium. First, where the light is going, minus from where the light is coming. Where the light is going? Mu3. From where the light is coming? For this medium, mu2, right? So, plus mu3 minus mu2 divided by, we have R2. All right. Of course, you can write all this formula in one single line, and that will help you in simply getting to the final answer. This one single formula you can use to get your answer in one single line, and you will be able to apply this in very, very complex cases. I'll show you how. All right. So first of all, again, I'll just quickly recap. Mu3 by V. The final image is formed over here. So mu3 by V mu1 by u. Where is the object? Object is in mu1. So mu1 by u is equal to, for the first surface, you see, the light is coming like this. So mu2 minus mu1 divided by r1. And for the second surface, mu3 minus mu2 divided by r2. Where, of course, you have to remember that v, u, r1 and r2 must be put with sign. You must put all these with sign. Now, if you have not written this formula and not understood the trick, please write it down on your own for at least once, and then you see how we will be solving very difficult questions based on this trick that we have. All right. Now, let's see another tricky situation. Over here, you have got combination of the lengths. Again, if you do it by the regular method, it will become very, very tough for you. But I'm just teaching you now how to write this equation. One single equation and all your problems would get solved, right? So I'm teaching you how to write this equation. First of all, let's write the right hand side of the equation first, because that is what is more tricky. Or even if you want, you can start with the left hand side. First, the left hand side equation talks about, first of all, image distance. So what is the final image? Final image is over here. And what is the image distance? V. And this image is formed in medium mu4. So I can write mu4 by V. All right. Minus. Where is the object? Object is in medium 1. So I'll write minus mu1 by U. All right. One side of the equation is over. Now we have to only worry about the curved surfaces, right? So for curved surfaces, the light will start from here, you know. So first surface it is going to encounter will be R1. So for R1, where the light is going? It is going to mu2. Where it is coming from? Mu1. So I'll write mu2 minus mu1. And when it is going to mu2 and coming from mu1, which surface is it encountering? It is encountering R1. So R1. All right. Plus the next surface that it enters is this curved surface. Correct? It is entering from mu2 and going to mu3. So it should be mu3 minus mu2. So plus mu3 minus mu2 divided by which radius? Well, R2. And finally, when you are going to this surface, if you see where it is going to mu4. Where it is coming from? It is coming from mu3. All right. So where it is going? Minus where it is coming from, right? So plus we'll have mu4 minus mu3 divided by, you have R3. Now I'm sure in NEET, they will not ask you more complicated than this. So if you learned how to write this equation, half of your job is done. Now it's simply how do we apply these equations? But you must remember that V, U, R, all of these things must be put with sign. If you're not putting it with sign, then there is no use, because you will end up making a mistake. So don't do that. All right. So I told you, when you're writing this, first thing is think where is the final image formed. So final image distance divided by the refractive index of that medium where the image is formed. All right. Then minus where the object is located. Object distance divided by the refractive index of that particular medium. Then see every surface, how the light is coming from the object and going and forming the image. So as the light passes, you have to see which medium it is going to, minus from which medium it is coming from, divided by that particular radius of curvature. All right, cool. Now, let's see a problem based on this. This is actually a JEE problem, but similar problems have occurred quite frequently even in our NEET exam. The question is, one plano-convex and one plano-concave lens of same radius of curvature R, but of different material, are joined side by side shown in the figure. If the refractive index of the material of one is mu1 and that of mu2 is and that of 2 is mu2, then the focal length of the combination is. Now look at this question. Do you think you will be able to do it? Well, try my trick, because if you do it with a regular method, it will become quite complicated, isn't it? So try this method. So first of all, we have to talk about the focal length of the combination. For focal length of the combination, you must understand one thing, that if the light is coming like this parallelly, it must refract and go and meet somewhere over here, right?
The light should come parallel to the surface and must refract and go and meet somewhere over here. The radius of this is given as capital R. All right. So wherever the image is getting formed, that will be the image distance, let us say from this point. All right. That distance itself would be, this V will be nothing but the focal length for this one, right? Okay. So how do we do? How do we do? Nothing is given. So we'll consider this to be air, right? So if it is air on this side and if it is air on this side, refractive index can be taken as 1. Refractive index can be taken as 1. All right. Now let's use our equation. What was the equation? If you recall, first of all, where the image is being formed in air, divided by V. V is nothing but F for us, isn't it? Because the light is coming from infinity. So 1 by V minus, where is the object located? The object is located at infinity because the light ray is coming from infinity. That is why it is parallel. So minus, in which medium? Air. So 1 by infinity is equal to, now we have to talk about the surface, the first surface. The light is coming from air and going into the first medium, right? So we must write it is going into mu1 coming from air divided by first radius of curvature. This is the surface, right? So what is the radius of curvature for a plane surface? It is infinity. So infinity, all right, plus, then when the light passes from this, it will enter and will encounter this curved surface, isn't it? Once it is encountering this curved surface, you can simply say light is going into mu2 and coming from mu1. So this should be mu2 minus mu1 divided by R. All right, divided by R, or you can say minus R. Why? Because I can substitute the value. You can see the radius will be on this and this side and the light is coming from the opposite side, right? So it is opposite to the direction of the incident ray. All right. Plus, finally, light will come out from here, mu2 to air. So I'll write 1 minus mu2 divided by R, which is a plane surface. This is a plane surface. So again, R will be what? Infinity. Of course, you know that this value will be 0. This value will be 0. This value will also be equal to 0. All right. 1 by V, which is nothing but, V is nothing but equal to F as we had discussed. So we get 1 by F is equal to mu2 minus mu1 divided by minus R. So from here, I can write that R is equal to mu1 minus mu2 divided by, sorry, we have to find focus, right? So F is equal to, or 1 by F is equal to mu1 minus mu2 by R, or I can write simply F is equal to R divided by mu1 minus mu2. Check which option does it match. R divided by mu1 minus mu2. Yes, it's option D, which would be the correct answer. So you see, a question which appears to be very complicated can be easily solved like this. Now I've got 2 more examples for you. I won't be solving the entire thing, but I'll help you to write the equation. And once you have written and once you know how to write the equation, you should be able to solve it very easily. All right. So let's see the next example. Okay. This is again a very good example. It's a question which has come long back, 2012, but it's again a very good example. And you can, of course, expect such a question if the NEET paper is made little tough, which after 2025 paper has been a norm. As you know, the questions are not though that simple as it used to be in 2016-15 like that, right? The paper is becoming tougher and tougher. So you should be ready with better concepts, better understanding, better formulas, better approach, and better shortcut methods. So the question is, a biconvex lens is formed with 2 thin plano-convex lenses as shown in the figure. The refractive index N of the first lens is 1.5 and that of the second lens is 1.2. Both the curved surfaces are of the same radius of curvature, which is 14 centimeter. For this biconvex lens of an object, the distance of 40 centimeter, object distance of 40 centimeter, the image distance would be. So they're saying that there is an object which is placed over here and this distance from here is 40 centimeter. They want us to find where the image is formed. Let us say this is V. All right. Now, first of all, identify the surfaces. How many surfaces the light is going to encounter? 1, 2, 3, isn't it? Right? So 3 surfaces. Perfect. Now, we are going to now use the trick. First of all, let's write the left hand side of the equation. So for left hand side of the equation, where is the object located? Now, as you know that over here, nothing is mentioned, isn't it? Shown in the figure, refractive index is of 1.5 and 1.2. No problem. Nothing is mentioned. So I can consider this side to be air. So refractive index will be 1. And this is also air. So refractive index is going to be 1. All right. Okay. Now let's solve this. So first of all, if the light ray starts from here, first of all, I can write the image is formed on this side. In which medium? In air. So I'll write 1 by V minus. The object is also located in the medium with refractive index 1, divide minus 1 by U. U is given to us as 40, and with the sign convention, as you know, I can write it as minus 40. Great. Is equal to, for the first surface, the light is coming from air and going into the lens. So it will be 1.5 minus 1 divided by R, and R should be positive. See the curvature, R should be positive, which is 14 centimeters. So plus 14, no problem. Plus, now light enters and there is a plane surface also. We should write for plane surface also. So for plane surface, it is going to be, light is going into 1.2 refractive index of medium, 1.2 minus 1.5 divided by, for this plane surface, the radius of curvature will be infinity. So infinity, correct? All right. Anyways, it will become 0, so it doesn't matter. And next, the light is coming from 1.2 and going to air. So it should be plus. We'll have 1 minus, light is going to air and coming from a refractive index of 1.2. So 1 minus 1.2 divided by the radius. So you see, this radius will be negative, which is minus 40. All right. So here you have the equation. If you just substitute this to 0, and you have got a very simple equation now, which is 1 by V plus, minus into minus will become plus 1 by 40 is equal to, this is 0.5 divided by 14, and this is minus, this is plus, this would be minus 0.2 and minus 14. So this would be plus 0.2 divided by 14. All right. Now you just have to solve for V, and I hope that you can easily solve. If you solve it, the correct answer comes out to be 40, right? So you can try this out on your own, but as far as the concept is concerned, and you can see that after a couple of questions, after practicing a couple of times, it should take you less than 1 minute to write this equation fast and then solve it for such a question which appears to be very, very complicated or complex. Only thing we need to remember, from where the light is coming, where is the object located, where is the image located, identify that. So the medium, check where is the object located, where is the image located. First of all, start with the image. So the medium in which the image is located, that is refractive index of that medium divided by image distance, minus the refractive index of that medium where the object is located, right, divided by the object distance, is equal to where the light is going minus where the light is coming from divided by that particular radius of the surface. All right. So it's pretty simple. You can again see a question 2011, again quite a complex question or good question came. We should say, water with refractive index 4 by 3 in the tank is 18 centimeter deep. Oil of refractive index 7 by 4 lies on the water, making a convex surface of radius of curvature R, which is equal to 6 centimeter as shown. Consider oil to act as a thin lens, an object S which is placed 24 centimeter above the water surface. The location of this image is at X centimeter above the bottom of the tank. See, look at the question, understand the question. There is an object which is located over here. Then you have a tank. The refractive index of the liquid is 4 by 3. On top of this, there is a water tank. Water with refractive index of 4 by 3 in a tank of 18 centimeter deep. So this entire depth is given to us. This is 18 centimeter. All right. Okay. And then there is a oil of refractive index. You have a curved surface of oil of refractive index like this. Okay. Of refractive index 7 by 4. The radius of curvature of this is 6 centimeter. And consider the oil to act as a thin lens. An object S is placed 24 centimeter above water. So above water, this is placed at 24 centimeter. Perfect. All right. Basically, we have to find where is the image formed. So let us say the image will be formed somewhere here. Let us say the image is formed from this surface. Let us say it is formed at some distance x. All right. From this interface, let us say it is formed at some distance x. This is simply like a combination of lens. We will say the light started from here. First of all, for the left hand side of the equation, what we should know, where is the image formed? The image answer is the image is formed in water, sir, right? So if image is formed in water, at what distance? Sir, it is at a distance x. Good. If it is formed at a distance x, then what is the refractive index of that medium? Sir, the refractive index of that medium is 4/3. So I should simply write 4/3 divided by x. Divided by x. As you can see, it is positive along the direction of light. Correct? Minus, where is the object? Object is in the air. How far is the object? Object is 24 centimeter from the interface. Good. 24 centimeters. So what is the object distance? 24. 24 or minus 24? It should be minus 24. Right. So in denominator, it would be minus 24. And in which medium it is? It is in air. So if it is in air, the refractive index of air is 1. So 1. Now we just have to consider about the curved surface, which is equal to, the light is coming from air and going into this oil. So where it is going? 7/4. 7/4. Where it is coming from? 1. Divided by the radius of curvature of the first surface, which is 6. Plus or minus? Plus, because this is the direction of the light and the radius of curvature will be also downwards. So plus 6. Correct? And for the next surface, which is this flat surface, again we can write the light is now going from oil to water. So for water, I can write 4/3 minus 7/4 divided by radius of curvature of this surface. What will be the radius of curvature of flat surface? Infinity. So you see, now that you have written down the equation, you just need to solve for x, right? Because this term will automatically become equal to 0, and you just solve for x. You'll get the distance from this point. Correct? All right. And then you can, if they're asking from the bottom, right? So just subtract it from 18. Now I'll leave this question, the final solution, up to you to get to the final answer. And you can easily solve this one, right? So once you have learned how to make this expression, then it becomes pretty simple. Then it's just basic mathematics, which is required on your part. So now with this explanation, I'm sure that you would have learned a very important concept where this topic actually is considered as a tough topic. But now with this approach, in one line with a little bit of practice, if you solve some PYQs based on a similar concept, you should be able to do such tough problems in less than a minute. So this is what is required to, get a very good rank in your NEET exam. If your preparation has to be up to that level where you are aiming for some top medical colleges in India, this is the amount of understanding that you require for a particular topic. Also, you have to know that it is very, very important for us to consider how we took the sign convention and how we are framing this shortcut trick. Shortcut trick is nothing new. It's just a superior method to solve a tough situation. All right. So if you understood this, then well done. Good job. All right. Now, let's see some complex questions or complicated questions that have come. Very recently, if you talk about this question, this was a question which was asked in the year 2025, just last year. All right. So this question came in NEET 2025. Very, very popular question, but also one of the toughest question of the paper. I'll read out the question. Two cities, X and Y, are connected by a regular bus service, with a bus leaving in either direction every T minutes. A girl is driving scooty with a speed of 60 km/h in the direction from X to Y, notices that a bus goes past her every 30 minutes in the direction of her motion. So there are two cities, X and Y. They're connected by some kind of a bus service. Every time, after a fixed period of time, one bus starts and is going in this direction from X city towards Y. All right. And the speed of the bus is fixed or constant. Let's say this is V. And one bus leaves every 30 minutes. All right. So let's say this time is t. So every time t it leaves. So what is the distance between two consecutive buses? They're moving with constant velocity. So the distance between two consecutive buses at any given instant of time will always be what? V into t. Next, see what happens. Okay. Now, they're also going in opposite direction, which that case also will take, don't worry. But now let's just take the this bus is going from X towards Y. All right. Then what happens? That a bus goes past every 30 minutes in the direction of her motion and every 10 minutes in the opposite direction. Choose the correct option for the time, for the period t, for the bus surface and the speed. Okay. All right. Now, there is a scooty which is moving in this direction with a speed of 60 km per hour. Now you see why this question is complex, because you have buses moving, you have the scooty moving, you have got buses moving at continuous interval. So how do you solve this question? Well, the simplest approach would be to solve it by the concept of relative velocity. Always remember, whenever you have got multiple things moving, 2 things moving, 3 things moving, always the approach should be to use and think in context of relative velocity. Now in relative velocity, we need to make something as an observer. In this case, let's make the scooty as observer. All right, so this becomes our observer. And if this becomes our observer, it has to come to rest. It has to come to rest. It cannot have any parameter of motion with itself. So once this becomes observer, let us say at t is equal to 0, my scooty is at rest and it sees a bus cross by. Let us say it has seen at t, just at t is equal to 0, it is seeing a bus just cross by. All right, like this, in this direction. So when it is going to see the next bus, because the next bus would have been at a distance of how much? V into t. The next bus is vt distance away from the first bus, right? The second question is, if this is the observer, this becomes my observer, this must come to rest. So what will it do with this parameter of motion? It must give its parameter of motion, which in this case is velocity, to this bus in opposite direction. So the direction of scooty is like this. It must give its parameter to the bus in opposite direction. So if the bus was moving with V and the scooty has given it 60 km per hour, like this, right? The net speed of the bus or the relative speed of the bus with respect to the scooty will become V minus 60. This is the relative speed of the bus with respect to the scooty times the time, which is 30 minutes. 30 minutes is half hour. So half must be equal to this distance, because this is V relative into time must be equal to distance, right? And distance is what? V into t. This becomes our equation number 1. This is our first equation. All right. This is our first equation. So let me just tell you what all things we have discussed till now. We have seen that the distance between two buses is fixed, which is going to be V into t. When we got this scooty to be at rest, which was moving with 60 km per hour, and we told that at t is equal to 0, just a bus is passing through. All right. So when will the next bus pass? After 30 minutes. So the next bus has to cover a distance of Vt in how much time? 30 minutes. So with what speed is this bus moving? It was moving with V minus 60 because of relative motion. Times in 30 minutes it will come, right? So in 30 minutes it will come. So half hour. This must be equal to Vt. This was the first equation that we have got. All right. I'm going to write it over here for this one. V minus 60 times 1 by 2 is equal to V into t. Equation 1 from the first case. Now the second case, understand. Let us say at t is equal to 0, the same time, at t is equal to 0, a bus is crossing in opposite direction. A bus crosses in opposite direction. The bus is moving with V and the scooty is moving with 60. And the distance between two buses, as we know, is always V into t, correct? So when the bus is moving in this direction and when we are making the scooty come to rest, then what happens? The relative velocity of this bus with respect to the scooty will become what? V plus 60. Because it will give its velocity to the bus in opposite direction. So it gets 60 like this, correct? So it will be V plus 60. And this happens every 10 minutes. This happens every 10 minutes. That means I can write 10 minutes is what? 1/6 of an hour, right? So I can write V plus 60 times 1/6 is equal to Vt. This becomes my second equation. If you look at both of these equations, the right hand side are equal. So I can equate the left hand side. I get V minus 60 into 1/2 is equal to V plus 60 times 1/6. This goes 3 times. And we can write this as 3V plus 180 is equal to V minus 60. Correct? Let me just clear things up a bit. Yeah. So I can write 3V plus 180 is equal to, on this side we are getting V minus 60. Let's take V on that side and bring 180 on this side, right? So what do you get? 240, correct? So yeah, you get 2V is equal to 240 and V will be equal to 120 meters per second. And if you take this 120 meters per second and place it and check the options, you get over here, right? Which is only one option for this. But we have to find this also, no problem. We can substitute. You have got this equation, correct? Substitute 120 for V. So you get 120 minus 60 divided by 2 is equal to 120 into T. So you see 120 minus 60 would be 60, 60 divided by 2 would be 30, 30 divided by 120 which will be 1/4 of an hour, which is 15 minutes. So option B should be the correct choice for this particular problem. So you see, this is the idea. That means not just you're going to learn how to solve question, you're also going to revise the concept in a very quick succession, and then you are going to learn those concepts in which there are some small nooks and corners where you could be trapped. We'll be doing regular questions, right from some basic level questions to better questions with full revision of the entire most important parts of the chapter, and solve all the previous year's question as well as some very good question, conceptual questions, which will help you in your NEET exam. So if you are a serious NEET aspirant and if you are looking for a serious preparation in these last days of your preparation and want to enhance and increase your score in physics and overall your rank, then this is a must session for you. All right, I'll see you in the main sessions.